Hello everyone. So today we'll be discussing interface in Java. In the last session, we have learned about different types of inheritance, and we discussed that there is and a very important concept of interface, which is used for multiple inheritance. So today we'll be discussing on interface, and we'll see some examples on how we use interface in Java programs. So what is an interface? Interface is basically a blueprint of a class. It contains static constants and abstract methods. In interface, how it is different from a class. A class can have variables and a class can have functions, but in interface, we do not have variables, normal variables. Those variables are basically constants, and the functions are abstract functions. That means we do not define the function in the interface. Where do we define it? We'll say in this example. Now, see this uh, example. So, in this example, we have, let me first put it in comment so that we can be able to compile this program. Okay, so now we have uh, this example wherein this is an interface. So how do we declare a class? We declare a class with a class keyword, class, and then we give the class name, and then here we give the functions like void f1, and then we write the body of the function. This is called the body, the statements. But in interface, when we make an interface, we use the keyword interface in place of class. So here the interface starts with interface keywords followed by the name of the interface. This is the name of the interface. And then we can have a list of functions, f1, f2, f3. But these functions are not defined. So these functions are supposed to be abstract function. A function which is not defined, it is only declared, is called an abstract function or abstract method. So in this program, what we have two interfaces. You can see we have two interfaces, interface 1 in1 and interface 2 in2, and altogether there are three functions in these two interfaces. So now when we make a child class from these interfaces, we use class. This is the name of the class. Suppose this the name of class is 1 2. Then we use implements keyword. In inheritance, we use extends keyword when the parents are classes. But in inheritance, when the parents are interfaces, we use implements keyword. So there's a difference between extending and a class or implementing an interface. In inheritance, when the parents are interface, where we use implements keyword. And now there are more than one parent. So this is what is called multiple inheritance. So what is multiple inheritance? As we have discussed in the previous session also, a class which has more than one parent is called multiple inheritance. So here class C12 has more than one parent, and those parents are interfaces. Now what we have to do, as soon as we define the class C12, first we have to complete all these functions which are mentioned in its parents. So we have to complete it. So we are completing it. We are adding public keyword, public void f1, similarly f2, similarly f3. So now this is an example of multiple inheritance where C12 is the child and IN1 and IN2 are the two parents. Now when we create the object of this C12 class, we can call its function f1, f2, f3, and suppose this also has its own function because it is a class, so it can have its own function also. So if we have its own function, we can write it this way, and then we can complete this function as well. So now we have four functions in this list on the C12 class. Three are from its parents, which have to be defined. Why? Because its parents have only mentioned that the program will have this function. It is not defined. So we have to define it and then we can use it. Now, if I save this program This is ex1. So I'll compile it. Let us compile and see how all these programs are executing. So I'll quickly use Java C. Java C is the command to compile the program. So when we are compiling it from the command prompt, we can do it this way. When we are using Visual Studio Code, we can directly click the run button. But here, first we have to compile the program. So we'll compile with Java C compiler. And if there will be error, the errors will be listed. Since there's no error, the program is correct. So now we can run it. And when we run it, we'll get, see, we called F1 function. So it is printing F1, then F2, then F3, and then F4. F4 is basically the F function. So this is what is an interface and how we implement multiple inheritance in Java. So an interface is basically a blueprint. What do we mean by blueprint? It is the structure of the number of functions that will be used in the program. And how it is relevant, why do we create it? I'll explain it in a few minutes. Interface is a mechanism to achieve abstraction. Abstraction is a concept of object-oriented programming where we don't give the complete detail of the functions. We only use the name of the function and the parameters. This is called abstraction. There can be only abstract methods in the Java interface. We cannot have method body. It is used to achieve abstraction and multiple inheritance in Java. So if in interview you are asked what is an interface, why it is used, so an interface in Java is a blueprint of a class. It has a static constants and abstract methods. It is used to achieve abstraction and multiple inheritance in Java. So you can leave it this. So this is what we can remember. In other words, you can say that interfaces can have abstract methods and variables. It cannot have a method body. So interfaces cannot have method body. A method body, what do we mean by method body? This is called the method body or the function body. The statements of the function are called the function body. Now, why do we create it? So I'll give you one very relevant example. Suppose we are going to buy a lot of things from the market. Okay, so what we do is we create a list of all those things that we have to purchase in the market. So why do we make a list? Because we want that if we forget, then we can check from the list and we can get all those items bought, and we don't come back without having one or two items that was supposed to be purchased. Now, in programming also the same thing happens. When we are discussing the project, usually when we do a large project, there are hundreds of functions to be implemented. So what we do first, when we sit and discuss the project, we create a list of all those functions that can be done in the program. And if we by mistake left out any one or two function, then the program will say that you are missing one or two functions and please complete it. For example, let me give you one example. I'll come to the same program. So this is a program, and here we have listed that there will be F1 function, F2 function, F3 function. Now suppose in the implementation part, when we are implementing it, we have not defined F1 function. We have defined F2 and F3 function, but we have not defined F1 function. So what will happen? So let me compile. It will mention here that you are missing F1 function. Now see, it is giving error that C12, this C12 function is not abstract and does not override abstract method F1. in IN1. If you can go through the error message, it is saying that it is not defining the F1 function in IN1. There is a IN1 interface. This IN1 interface has an F1 function, and this F1 function is not defined as C12. So as soon as we create a list of functions to be used in the inside the interface, then there are chances in long projects in bigger projects that we may miss out one or two functions. Then it will be the responsibility of the compiler that it will alert us that you are missing some of them. So I'll complete this program. See, now I have pasted it again. I'll save this function. I'll come back to the prompt and I'll try to compile this. Now you can see that this program will compile and the errors are gone because we have completed all those functions. So this is the meaning of a blueprint of a class. When we talk about blueprint of a class, that means rather an interface in Java is a blueprint of a project, we can say. That will be more relevant word to be used. So an interface in Java is a blueprint of a project. It has a static constants and abstract methods. What do we mean by abstract method? That these methods do not have the body. These functions do not have the body. These functions are defined in the child class. And by blueprint, we mean that it contains the list of functions to be used in the program. And if we do not implement any of those functions in the child class, then the program will not compile and it will give error. So this is the concept of interface. We'll quickly see some more example. In interface, we use the keyword implement. So it is also to be remembered that when we use interface, in case of interface, we use the keyword implements, not extends. Okay, extends used in the inheritance in the class. So it is used for multiple inheritance because more than one interface can exist as a parent, and implements keyword are used. So if we want to list out the difference between a class and an interface, so in case of class, there can be only one parent class. In case of interface, there can be any number of parent interfaces, number one. Number two, shall we not list them? Yes, we should. So what are the differences between a class and an interface? So number one, a class can have only one parent class, but multiple parent interfaces. This is the major difference. Then a class can have variables and functions. Functions are also called methods, but interface function and functions with body, variable statement. Where interface can have only constants and abstract methods. Abstract methods means functions which are not defined. So these are two very important differences between a class and interface. So a class is declared with class keyword, whereas interface is declared with interface interface keyword And fourth difference is that we use, uh, I can put it here. In case of interval, we use keyword implements, not extents, as is used in class. Extents because it is used in case of class. So these are the major differences when we talk about class and interface. These questions are being asked in interview when you write their writing Java. So it is very important to remember. I'll be putting all these things in the video description so you can get this description and details from the video descriptions as well. Now I'll quickly move on to my next program. So I'll save it, I'll close it, and I'll open another program. So let us start with example 2. Java. Yes. So in this example, what we want to study that there's the same program with this extra code. So what is this? Let us see. Now, when we are doing multiple interface, multiple inheritance, that means there will be more than one parent. So as we know that as a parent, there can be one child, one parent class and multiple interfaces. So in this case, the class C12 will have one parent class C. So we are using extends keyword and two parent interface in1 and in2. So we are using implements keyword. In the last example, this was not there. So there was only two parent interfaces. But as per rule, a class can have one class as a parent also. So here we are using one class as a parent and two interface as a parent. So there is also an example of multiple inheritance where in this class C12 has a class and two interfaces as parent. That means it has three parent entities. Now, since in1, in2 has three functions, so these have to be completed, and this this parent class has the function already defined, so we are not defining it. Now here, if we create the object of this C12, we can call all those functions. So what is the difference here? That in this example, we have one parent class as well as two parent interfaces. Let me quickly save this program and then I'll compile it. Example 2.check. So it is done. As we are calling the object, you can see when we are creating the object of this class, we are calling F1, F2 function, and all these functions are getting executed. Now let us come to another example. Example 3.java. What we want to see here is that, okay, there is the same example. So I'll leave it. I'll open example 4. Now this is very interesting. Here you can see we have an interface I1 and then we are creating a child class C1, child class C. So class C is implementing I1. But as you can see that in this child, we are not completing these two functions. We are completing only one function, and it has, since it is a class, it can have its own function as well. So F2 function is not there. That means class C is not complete. We cannot create object of class C. And another very important difference, let us come to the first example. Let me open example 1. Another very important difference is that we cannot create object of interface. That is, we cannot instantiate it. Why? Because it is not complete. We cannot uh, create object because once the object is created, we'll be using uh, the functions to be called, and thus functions are not complete, so it will not be able to run the program. So you can see in this example, we have an interface I1, and this has been implemented by a class, but this class is not completing the F2 function. So in that case, this class will be called abstract. So what is an abstract class? A class which is not complete is called an abstract class. Why it is not complete? Because its function F2 body is not yet defined. So what we have to do, we cannot create object of an abstract class as well, because an object can only be created when the functions are totally defined. So one function is not defined here, so we will not be able to create the object. So that is why we are calling it as an abstract. Now, first what we have to do, we have to create an object of this class C, and I mean create a child class of this C. So class C2 extends C1, and here we are completing it. Now for this class C2, this is child of C, so it will have F1 and X1 function as well, and this F2 function, which was not defined from the I1, has now been defined. So now we will be creating object of this class C2, and we can call all those functions. So this is also possible that interface can be completed in more than one class as multi-level inheritance. We have already discussed this multi-level inheritance. When there are more than one level of inheritance, it's called multi-level inheritance. So interface I1, you can see, has two functions. All these two functions must be defined before we can create object, but the class which is implementing it is not defining F2 function. So we have to use the keyword abstract here, otherwise the program will not compile. It will give error. So now this is also incomplete. Interface is also incomplete, and abstract class is also incomplete. Now we have to first complete it in the child class. So this C2 is not a complete class. It's now completing all those functions which were left, and then we can create the object of the C2 class. So I'll try to compile it. Java C example 4.java. C F1 function. Okay. The error is that I have mentioned X as small and it was written capital in the name, so it will run this way. So you can see this is possible. But what will happen if I do not use this abstract keyword? Let me just do it normally and try to see what is happening. I'll try to compile this program. So it will give an error that class C is not complete. We cannot class C is not abstract and does not override abstract method F2. So it is mentioning that class C, you cannot use class C normally. It has to be an abstract class because it is not defining the function. So abstract is to be used. Abstract is a Java keyword which is used with a class when the class has some function which are not defined. So abstract class is an incomplete class. It needs to be completed before it can be instantiated. That means we cannot create object of the abstract class as well. So this is another example of interface where the functions listed in the interface are not defined at one level, it is defined at two levels. And the first level of inheritance, we are defining one function. In the next level, we are defining another function. And now at this level, at the C2 level, all the functions are defined. So now we can create the object and use the function. So let us come to another example. Quickly use another example. Example 5.java. Let's see. Example 6. Example 6. Example 6 is based on function overriding. So overriding means repeating a function which is already existing, and we have discussed in previous session overloading. What is overloading? Overloading means we can create more than one function by the same name but with different parameters, and overriding is creating the same function in the child class as it exists in the parent class. So let's see what is function overriding. This is overriding. Do remember that this is not overloading. It is a feature of object-oriented programming in which the child class has a function of exactly same signature. We mean name and parameter as function of the parent class. So if you can see here in this example, class C1 is the parent class C2 is its child class, and child class has a function with the same signature. That means everything is same. Function, return type, name, parameter. Basically, name and parameters have to be same. So name and parameters are same. So this is called function overriding. When a child class has a function with the same signature, same name, and same parameter as a function in the parent class, then this is called function overriding. So what will happen in this case? Now, when we create the object of this C2 class, we will call F1 function and we will call F2 function, but this F2 function will get hide by this new F2 function. A new version of that F2 function will be called. The previous function which was existing in the parent will not be able to call, because we are calling by the obj.f2. So there is one new f2 available, so new f2 will be called. In such situation, preference is given to the child class function, the object of the child class called the child class function. The base class function gets hidden. This is used in situation where we want a function of parent class to be used in a modified form in the child class. So it has a lot of things. Let us go one by one. So this is one part, then this is the second part that we have to understand. This is the second point in function overriding, and then this is the third part of function overriding. So what are those important points in function overriding? So first of all, this is function overriding. So what is function overriding? Function overriding is a feature of object-oriented programming in which the child class has a function of exactly same name and parameter as a function of the parent class. You can see in the example, the child class C2 has a function F2 which is exactly similar to the function F2 of the parent class. So this is called function overriding. Now what will happen in such situation? Preference is given to the child class function. That means if we create the object of the child class and call the F2 function, then preference will be given to the child class function. This will be called and this will not be called. This will be hide by this new version. So many times what happens, a new version of the same thing is also created. So when a new version comes, the older version has to be not used in the program. So it is automatically hidden if we do it by function overriding. So this is function overriding. Now, what are the differences between function overloading and function overriding? So I'll quickly make some points. If you remember, we have discussed function overloading and function overriding. So these differences are being asked between function overloading and function overriding. So number one, we can keep it at the top itself so that we can move here. Number one, function overriding occurs only in inheritance. Because when the child class has a function with the same name, then only overriding with occur. So it is a case of inheritance, but function overloading can be in same class or in child class. In both cases, it is possible. So if a function has same name but different parameter, it can be in the same class or it can be in the different class. Then it's called function overloading. That means function overloading. What is function overriding? The child class's function is exactly same name and parameter. This is function overriding. And what is function overloading? More than one function in a class or child class with same name but different parameter. The parameters have to be different. It can be in the same class, it can be in the child class. Function overloading occurs only in inheritance, but function overloading can be in same class or in child class. This is point number 2. And then we have point number 3. If we can see any more difference in function overloading and overriding. So function overriding is basically a case of inheritance. Function overloading can occur without inheritance also, and it can be in the same class or in the second class, but function overriding has to be in the parent and child class. In function overloading, all the functions are available to be used, but in case of function overriding, the base class function is not available. You can say. So these are the 3 important points which we should be knowing in case of function overloading and function overriding. So these are the differences, and this is the example of function overriding. You can quickly see once again in function overriding. We have a child class which has the same function with the same name and the same parameter as a function in the parent class and the child class. Then this is called function overriding. I hope this session was interesting, and please note down that the code will be available in the video description. Try to understand, run the programs, listen to the video twice and thrice, pause the video, run the program, see the output, and try to understand the concept. Thank you very much.